In this problem, we'll look at a simple chemical stoichiometry problem, and we're asked in this one to consider potassium reacting with chlorine. So in these kinds of problems, it's your job to come up with the so-called recipe by writing out a balanced chemical equation. So that's exactly what they want us to do in part A. Write out balanced equation for the reaction between these two elements. Don't forget that chlorine is one of our diatomics. We've got two elements reacting. This looks like it's going to be a synthesis reaction. So the potassium and the chlorine will combine to form potassium chloride. Potassium's oxidation state is 1 plus, chlorine's is 1 minus. So the correct formula is KCl, and then I simply have to balance the equation. And in these problems, the coefficients provide the molar ratios for relating any two components of the reaction or of the recipe. So here we're restricted to molar ratios. This is a little bit different than dealing with a regular recipe. So let's see what they want us to do in this one. So we're provided with a certain amount of chlorine reacting, and we'd like to see what the theoretical yield will be. Theoretical yield, remember, is a predicted amount of product. It's always a calculated value. We don't have to do the experiment to find this value. And of course, we'll start with the given amount of chlorine. And because chlorine is diatomic, its molar mass is twice just regular Cl, so 70.90. Obviously, the labels cancel out. Now we're allowed to use the ratio between the chlorine and the potassium chloride. And when you look at the coefficients, it's 1 to 2 or 2 to 1. We're going to get twice as many moles of potassium chloride. So now we're allowed to use the ratio. And then finally, they want the answer in grams. So we'll multiply by the molar mass of the product. Again, our labels cancel out. We do all the math. We're going to use three significant figures, and we get 1,150 kilograms of potassium chloride. So, chemical stoichiometry problems, you come up with the recipe by developing a balanced chemical equation. The ratios are the coefficients found in the balanced equation, and they are molar ratios.